Let us go to now problem number 2, where again the mass is 1 kg. What is given is temperature of 68 degrees centigrade. What is also given now, other property is enthalpy 2200, alright. So I got two properties now, temperature and enthalpy, and I have to get all other properties. So what I will do, because I have been given temperature now, I will go to table number 1 and compare these values of given enthalpy with HF and Hg and locate in which region I lie first and then get the properties. So let us now go to problem number 2 and let us go to table number 1. So here is table 1 and look at 68 point temperature here. So this is 68 degrees centigrade. Okay. So please write down all the properties first and then we will come to the solution of this problem. So basically, because we have been given the value of H, which is 2200, and this is the value of HF and this is the value of, alright. So we can locate based on this. If I see HF and Hg for 68, we can see that where we are. So HF is 284 and Hg is 2622, and we can note that the value of given H lies between these two, telling us that we are in a weight or two phase mixture. Now let us go back and solve the problem. Okay. Question number 2, m is equal to 1 kg, given the value of H is 2200 kilojoule and T is equal to 68 degrees centigrade. Please note that because m is equal to 1 kg, we can write H is equal to 2200 per kg also, alright. If had it been 2 kg and this was given the value of 2200, then we will have to get kilojoule per kg for that value of H and use that in the steam table, as what we saw from table 1, and that at 68 degrees centigrade we get the value of HF is equal to 284.68 kilojoule per kg and Hg is equal to 2622.7 kilojoule per kg, alright. Depending on this, what we get is HFG is equal to 2388.0 kilojoule per kg. It is not very important for us. So what do we see, that the value of 2200 is between HF and Hg. So we can say that HF is less than H less than Hg, and therefore we know that this is two phase region. That means we are under the dome again. We know that we are under two phase, we are under the dome. We first want to value the value of x. And how do we get the value of x? Because now we know the formulation that H is equal to HF plus x time HFG. What is the H value given to us is 2200 kilojoule per kg is equal to HF, which is 284.68 plus x time HFG, which is 2388 as given over here. From here what we get is x is equal to 0.8192. This is very important. Once we get the value of x, we can get all the properties, and that is not a problem at all. So I can now get u is equal to uf plus x time ufg as we have done earlier, s is equal to sf plus x time sfg, and v is equal to vf plus x time vfg. I can use this now and get all the calculations done, which I am not going to do all the calculations. Value of u is equal to 2071.86 kilojoule per kg. Value of v is 4.4797 meter cube per kg, and value of s is 6.5448 kilojoule per kg Kelvin. And now I know that we are again talking about mass is equal to 1 kg, alright, and therefore the same table will come as values for this. So we will have 2077.8, 6.54 and 4.47 meter cube kilojoule per Kelvin and kilojoules as the final answers. This value, just to correct, this is 2338, and similarly I can use 2338 here. So here in this table now, just by knowing the two values, T is equal to 68 degrees centigrade and H is equal to 2200, we can get all other values, that V is equal to 4.47 meter cube, U is equal to 2071, S is equal to 6.54, and X is equal to, as we found first, as equal to 0.8192. Although these values have been given larger decimal points, you can actually just have first two digits after the decimal, and that is good enough. With this background now, let us get to the third problem, which is mass is 3 kg now here in this case. So earlier we had mass as 1 kg or unit mass, unit kg, 1 kg. Here we have got 3 kg mass, and for which now we have got the properties. The enthalpy has been given as 2200 kilojoules, and temperature has been given as now 68.5. Alright, the temperature is 68.5. This will now create a problem, and let us now see how do we solve the problems. So first important thing is, let us go to the temperature table 1 and locate all the values, and then come back to solving the problems. Okay. So let us go to table 1, go to 68.5 and then solve the problem. This is table 1 where we want to get the values at 68.5. What you can note here is, we do not have a value for 68.5, but we have got a value for 68 and value for 69. So what do we do in this case? We will have to basically now interpolate the values between 68 and 69. 68.5 happens to be a midpoint, we can take average of two values. For example, if this is HF 68 and this is HF 69, we can just take average of these two values. Similarly, HFG we can take average of these values, and this can be done for all true. But if this is not average, for example, it could be 68.3, then correspondingly we have to linearly interpolate between this 68 and 69, alright. So that linear interpolation can be done easily. For the simplicity sake, I am going to take average of these values between 68 and 69, okay. So note down the values for 68, note down the values for 69 and go back to the calculation. So after noting all those values, let us solve the question number 3. So question number 3, what is given to us is M is equal to 3 kg, H is equal to 2200 kilojoules, and temperature has been given as 68.5 degree centigrade. What we just saw, that we had values for 68 degree centigrade and we have values for 69 degree centigrade. So if I write those values, HF is equal to 284.68, it is 288.87 over here, then HFG is equal to 2338 kilojoule per kg here, then HFG is equal to 2335.5 kilojoule per kg here, and Hg is equal to 2622.7 kilojoule per kg at this point, and Hg is equal to 2624.4 kilojoule per kg here. So what we can do here, basically by interpolating this, I will get the values of HF at 68.5. We just interpolate between this value and this value. We get HF at 68.5 is equal to 286.7 kilojoule per kg. Then we can say HFG at 68.5 is equal to 2336, alright, between these two values, kilojoule per kg, and Hg at 68.5 is equal to 2623 kilojoule per kg. So similar thing are done for U, S and V. I will interpolate the values and get it for 68.5 degree centigrade. Now we know that the H is given as 2200, but in our case the values are given at 3 kg. So what we have to do is, H is equal to, therefore 2200 divided by 3, and that is 733.33 kilojoule per kg. It is very important to understand that the values that are given are were not per kg, therefore we will have to find out per kg value, which is 733.33 in this case. And therefore, if I compare this H value with HF and Hg, we understand that HF is less than H less than Hg. Alright. So, HF 68.5 is 286.7, Hg 68.5 is 2623, while what we have is 733. And therefore, we know that again this is two phase region. Alright. That means we have to find out what is X, and I can get the value of X again as H is equal to HF plus X time HFG, and this has to be done at 68.5 degrees centigrade. So, I know that 733.33 now is equal to 286.775 plus X time HFG, which is what we have evaluated at 68.5. So, 2336.775, and from here I will see that X is equal to 0.1911. Alright. So, once I get the value of X as 0.1911, I can now use the same thing to calculate the values of U, V and S by using the formulation as U is equal to UF plus X time UFG, V is equal to Vf plus X time Vfg, and similarly S is equal to Sf plus X time Sfg. Okay, let us go to the next page. So, I get V is equal to Vf plus X time Vfg. If I put these values, I will get 1.024 meter cube per kg. I get U is equal to 703.38 kilojoule per kg, and I will get S is equal to 2.24 kilojoule per kg Kelvin. Now, we know that mass is equal to 3 kg for us. Alright. Therefore, I will have to multiply by 3 to all these values, and therefore, now my V will be equal to 3.07 meter cube, U will be equal to 2110 kilojoule, and S will be equal to this S value into 3, that what we get as 6.73 kilojoule per Kelvin, and this is the final answer. So, coming back to the table, for the third problem, for H is equal to 2200 kilojoule for 3 kg, T is equal to 68.5 degrees centigrade, the properties which we calculated are V is equal to 3.07 meter cube, U is equal to 2110 kilojoule, H was given to us as 2200, and S is equal to 6.73, and X we had calculated as 0.19, telling us that this was in a two phase region. So, this is the way we will have to calculate. First, understand the zone in which it is, also ensure that the values are given as per kg or for 3 kgs or for 4 kgs, whatever, and correspondingly to convert into kilojoule per kg, and then answer the questions accordingly. Thank you very much.